10.5a Law of Sines. In this section, we're learning how to find the area of a triangle given side angle side SAS information and solve for missing parts of a triangle like angles and side lengths using something called the law of sines. Let's talk about finding the area of a triangle. So let's recap how to label triangle sides and angles first. So if I wanted to draw a triangle, I'll just call this A, B, and C. You can put the letters anywhere as long as the same letters are across from each other. So side A, lowercase a, side B, lowercase side length C across from angle C. I'm going to go ahead and draw in a height here. So if I have an altitude or height h. Normally, if we're given this, we know that we can find the area. Oops, let me try that again. Let's find the area of a triangle is 1/2 base times height. Right, 1/2 base times height. In this case, the base also happens to have the letter B, which is convenient. Right, we have 1/2 the base times the height, or base times height divided by 2, and that would give you the area. Well, what if you're not given the height? Let's say you were given 2 side lengths and the angle between. Okay, if you're given a side angle side situation, or you're given a side, an angle, and side information, you're still able to find the area using this same formula. So we have 1/2 base, which is B, but we need to figure out H in terms of the given information, so C, A, or B. So let's think about this. If I'm given this portion right here, how can I relate these letters to each other? So notice I have a right triangle there. So with that right triangle, I can do the following. I can find the sine of angle A, right? Sine of angle A is opposite over hypotenuse. So sine of angle A is H over C. And I can isolate the height by multiplying by C on both sides. So the height is C sine of angle A. See that? If I multiply by C on both sides, right? I get the height is equal to C sine of A. So I can still use this area formula of 1/2 base times height. So I have 1/2 base, which is still B, but instead of the height, I can substitute it with C sine of angle A. So the area 1/2 BC sine of angle A is a formula for oblique triangles. This will not be provided to you, so you'll need to either memorize it or know this process of finding the sine of that given angle to figure it out in relationship with the height. Now I can do the same thing from the perspective of angle C or angle B. So we actually get 1/2 AB sine of angle C as an area formula. I could also do 1/2 AC sine of angle B. So again, this is just doing the same thing that I did here, but looking at from the perspective of the other two angles. So the area is 1/2 BC sine of A, 1/2 AB sine of C, or 1/2 AC sine of angle B. So the easy way to remember this is that the area of an oblique triangle just means a non-right triangle, so an acute angle or an obtuse angle can be given by the following. This is if you're given side angle side information. So again, if you're given a side length, an angle, and a side length, you can do the following. The area is going to be as follows. 1/2, it's going to be side length 1, right? Because you're given 2 side length 1, times side length 2, right, the other side length, times the sine of the angle between, sine of the angle between them, okay? So that's how it can be done. Let's take a look at an example here. Find the area rounding to the nearest tenth. You're given information of a triangle as follows. So you could draw out the triangle. You don't have to, but I'll just go ahead and draw it out. So I'll label angle A here, 102 degrees. A, B, and C can go anywhere. B is 90 meters. C is 52 meters. So note that I have a side, an angle, and side situation. So I have enough information to be able to find the area of this oblique triangle, an obtuse triangle in this case. So you have two options to go about this. You can either use a formula where the area is 1/2 AB sine of C, BC sine of A, that type of a thing, right? So in this case, I'm going to have BC sine of angle A right? BC sine of angle A. So you would remember that formula. Something to help you remember this is like each of the letters are only used once, so that could be a clue. If you wanted to memorize the formula, you could. And then plug in the values. So 90, C is 52, sine of angle A, it's 102 degrees. Make sure you're in degree mode. Enter that into your calculator all in one go. And you should get 2288.8. And since the units are in meters, square meters. So that's your final answer. So you can either memorize the formulas, noticing that it's 1/2 like A, B, C, B, C, A, C, B, that type of a thing where it's going to be sine of the angle. Or remember, this is when you're given a side angle side situation. So you could just use that pattern of area equals 1/2 side length 1, side length 2, and then sine of the angle between 102 degrees. Okay, that's probably easier to remember. Whichever way is fine, and you'll get the same exact answer. Okay, let's try one more example. Find the area rounding to the nearest tenth, and you're given this triangle. Okay, so you have two options. You can just see that you have a side, an angle between, and a side. So use that pattern to help you find the area. Or if you like using the formula way where you know the letters, you can just label these using whatever letters you want. So you can label like angle A, B, C, side B, side A, side C. And then here you would have to use area equals AC sine of angle B. Okay, so I'm just going to go ahead and use a more intuitive way, what I feel is a more intuitive way, where you have area equals 1/2 a given side, right, and sine of the angle between those two sides. And our answer is 47.9 square feet. All right, you try. Find the area round to the nearest tenth. Okay, so here you have to be careful. You notice that you're given two side lengths, and you have to use the angle between the two side lengths. So I need to figure out what that angle is. And we can do that because we know that other two angle measures. So 130, right, subtract from 180, so that's going to be 50 degrees. So the area would be side length 1/2, right, side length 1, side length 2, sine of the angle between, so it's 50 degrees. Plug it into your calculator all in one go, and you get 5.7 square meters. So again, be careful that you are using side, right, 1/2 side and side, but that the angle that you're using is between the two side lengths.